everybody. We're starting on time in an effort to end on time. So, that always helps. Welcome to this talk. My name is Pippa. I am a senior SDE with AWS, specifically with EC2. And today we embark on a little bit of a tale of good intentions, okay milestones and goals, and so many bugs as we talk about rewriting a data store at millions of TPS. So just give you a sense of where we're going today. I'll start with some context, both on the tool that we decided needed a new data store and the event which triggered the decision to give it a new data store. Then we're going to work through a timeline of the last 2 years and a bit of development on this project. And we'll close out recapping some of the lessons we learned and relearned, and maybe learned again along the way. And if I got all my timing right, there will be time for Q&A at the end. I'm going to add, there's a lot more technical details that I could put into this talk, and then I would end up talking for like 3 hours, and I've only been allocated 30 minutes. So rather than turning this talk into a timeline like my project, if I run out of stuff, come find me afterwards. I'm here all day, and I am more than happy to talk the details with you. So, what is the service? I haven't really talked about it yet. Back in 2012, in the before times of EC2, when it was new and small, some very bright developers were looking at this distributed microservices system of the EC2 control plane, and they were trying to debug stuff. And they decided what they needed was a distributed log tracing tool. So they built it. The first commit message that I found from 2012 had the words hackety hack. So that gives you a sense of the history of the service. And because I can't call it the DLT without thinking it's going to get a driver's license, I'm going to call it Heimdall because Heimdall sees all. Heimdall at its super high level architectural is 2 main components. It has a bunch of queues which tell us, hey, there's log files that need indexing. We have a set of servers which create a reverse index from a request ID. So that's, I made a call to the EC2 API. It has a request ID. We take that request ID and we create a reverse index to all of the log file locations where that request ID exists. That gets stored in the data store. We have a reading system which you can give it a request ID. So you've contacted support with your failed request. You gave them a request ID. They put it into this website, and they get all the logs from every microservice, only the ones that are part of that request, though. So that's our architecture. And as is the nature of good ideas and cool systems like this, it's been growing since 2012. And it is used by pretty much all of EC2, as well as some other AWS services for precisely this reason. For almost 10 years, this thing has just worked. It's had some bug fixes and things. It had one major rewrite where it changed languages. But for the most part, people are relying on this tool, and they can. In 2019, it became a first-class citizen, which means my team owns it and some other operational tools that EC2 uses. And we have an on-call rotation. If it goes down, our pages go off. It's reliable. Then this happened. December 2021. I had a very bad night that night. just like US East 1, the largest AWS region, had a network event. If you want the full details, go look it up on AWS Messaging Hub. Like, you could just Google AWS US East 1 2021. You'll find it. There's a bunch of juicy details in there. We have shared what happened. I'm going to focus on this one service, Heimdall, and its impact. So, 6 p.m. roughly, SAST, this graph is in UTC. When that line falls over, we don't get pages firing, we get Slack messages saying, hey, monitoring's down. Now, I am more worried when I get a Slack message saying something's down than when my pager goes off, because that's a bigger event. Silence is scary. In these events, everybody goes, they load their dashboards, they look at their metrics, they're empty because monitoring's down. So now they want to look at the logs, because if their services are still running, they should be producing logs. We have several tools that help people go from metrics to a request ID, then they take that request ID and they put it in Heimdall, and they've got their logs. Those were all also down because monitoring. So our senior engineers who still remember how to do things the old-fashioned way used SSH and tail, and yes, that is how we were looking at our logs. It's effective. It doesn't go down. But they couldn't share any of it. They could get the request logs for a single microservice. And then when something was wrong, they had to engage another team to SSH onto their servers and look at their logs. And, that took time because our service was down. It took EC2 that much longer to figure out what's going on, where are we losing network, what's broken. And so why were we broken? Well, obviously we weren't processing as many logs as we should have been. Interestingly, for the most part, the logs were getting shipped off servers and we just weren't being able to process them. So, okay, all very well and good. What happens when the network recovers? What is missing in this diagram is a mechanism to sideline old messages. So at this point, the network's recovered. We have to work through 6 hours worth of people failing to call EC2 before we can process messages from now. EC2 was really hoping we could just prove to them that they were back up. Yeah, we failed that one too. And so if I go back to this graph, you will notice that we went from happy case 5 billion requests per hour to the top of that is more than 10 billion requests in that hour. So as you can imagine, we found some limits. We found the scaling cliff. And that was our data store. So our DynamoDB data store, Dynamo's great. They were happy with our 5 billion per hour sharded across multiple accounts and multiple tables. But if you want to multiply that by 2 within a few minutes, you get throttled heavily. And so in the short term, we did some scaling, we spoke to the DynamoDB team, we got all of our limits raised. We even got permission to be able to do that whenever we need to moving forward. So we have all of that. But the writing was on the wall. DynamoDB at this point is a dependency that we need to be careful about. Not because they're bad, but because we're using them really heavily. And so what do? Short term, as I said, we get the scaling limits increased. We push out the cliff edge, we make it sometime, buy ourselves some time. We have alarms, we have metrics. When we're getting close, we know who to engage, we can get the limits increased. I promise you do not want to be doing that at 2 a.m. So, not a long-term fix. So long-term, we need to look at our architecture again. And we needed to look not just at our, we're writing a lot of data here, but we're also looking at the shape of how we read that data. What we've found is because our readers are humans, and humans interact with systems a lot more slowly than computers do, we read a very small fraction of what we write. We read 0.0001, that was 4 zeros, yes, % of what we write. And we can't do sampling and stuff because for all eternity we have done all the requests, so we can't just turn on to sampling and do less. So we had to build a design with as few dependencies as possible, because in EC2 we're terrified of dependencies because all of you cry if we go down. And we needed something that is simple enough that my team, who is owning 3 different operational tools, don't also have to become database experts. And then it needs to be super fast, both for a ridiculous number of writes, right? We were at this point 5 billion an hour, and not that many reads. But those reads, right, still need to be fast. So we did a whole bunch of research, we read a bunch of papers, and we've designed a system which is a tree-based system with some compaction mechanisms, which in theory looks amazing. We did a whole bunch of maths. We figured out a way of doing it where our only dependency would be S3. And S3 buckets are great. They don't go down. They stay there, you write your data to them, you read your data from them. Here's how long we thought it would take. For those of you who are really quick at math, that's 12 weeks. Oh, I'm so glad you laughed. Yes. At this point, one of our senior managers, in a one-on-one with one of the senior engineers who was proposing this design, said, "Usually these kinds of things take 2 to 3 years. Are you sure this is feasible?" Said engineer very confidently responded, "No, 3 months sounds about right." Lesson learned: major re-architecture projects take a lot longer than you think they will, particularly when you're working at this kind of a scale. So here's our timeline. This is what we're expecting, And if you're very clever at spatial awareness, you'll realize that's about a quarter of my 2-year timeline. So I'm padding this to it'll be 6 months, not 3. So, some highlights of year 1. Yes. Our first 6 weeks of coding were fantastic. We get to choose a language we like, we get to use modern dependencies, not the latest and greatest, because later we have to integrate with the old system. But, you don't have to use something that was the new hotness 10 years ago. That was fantastic. All our unit tests were passing, our integration tests were passing. It's fantastic. And then we start looking at integration. And we realized that some of the points where we have to touch this code, nobody has even looked at it since 2015 when it was rewritten. Which means that the engineer who did the rewrite looked at it, and for the rest of it, it's just worked. And I don't think anybody on my team actually owned the service in 2015. Most of us joined that year. So, legacy systems, and when I say legacy, I really actually mean any system that's older than 2 years. Those are difficult to modify. You're gonna find weird things in there, and it might be just, I'm not used to this language, or it might actually be, wait, how did that ever work? Yeah, I've said that a lot of times. So, our timeline is already running over. just by expanding that little integration block there. But now we also needed to rethink our rollout plan. And the way we chose to do this was build an entire new fleet running in parallel to our production fleet and taking a portion of our production traffic, so up to about 50%. I will say this is one of the best decisions we made in the entire project, because the first time we deployed the code to production, we had a memory leak. Crashed the servers as soon as it started running. Don't do that to your production fleet, ever. So that has been a story of things that worked in this project, and we have continued doing that throughout the course of the last 2 years, which has caught memory leaks more than once. It has caught CPU throttling. It has caught I/O throttling when we were using EBS volumes. If you don't know, EBS can throttle you. At some point, we ran out of threads. Like, if you can think of something that can go wrong with a server, we've done it. Usually to about 200 servers at once. But it worked. It was in production. That's good. So our architecture goes from this to this. That's great. It's still, working. Our timeline went from here. Now we've just, we switched 2 colors, if you noticed, and expanded. So we're getting a little further along here. Now, this is a sore point for a lot of people. When you own more than one thing, you don't just get to work on the new shiny one, even though that's the one we want to be working on. So we had operational events. We melted other databases. Well, I say melted, but other stuff fell over. We had scaling issues with other services, like a bunch of stuff. We also had new team members joining. We had old team members leaving. That's an unexpected cost. And so, lesson here, when you're planning time on a project, account for all the stuff that's not that project. And your timeline goes from this to this. Because some of those operational events are stop the world. Oh, you thought you were doing Scrum? That's nice. Cancel your sprint, try again next time. We've had a few of those. It happens. When you're running at scale, it happens. And I'm going to give you the last highlight of year 1, which, seriously, this happened at the end of year 1, and it should have been earlier. And this is the question our stakeholders care about. How do you know for sure that the data you're returning from the new store is correct? Yeah. So, scale check. While we've been developing for a year, this is 1 year on from that event. If you can read the numbers on this graph, we have gone from 5 billion per hour to 10 billion per hour, just normal use. This is US East 1. This is if I sum across all AWS regions, bearing in mind that we keep adding new ones and, people like AWS for some reason. So we're sitting at 30 billion requests per hour being written across the AWS regions. Just a little bit of data. And our timeline just, put a little bit of a line in there. That's December. So, highlights of year 2. Yeah, parity metrics. First thing that we did in year 2 is we told our reader to now go look at both data stores every time it gets a request and do a diff. If it didn't find all the data in the new data store, it needed to post a metric, and this is actually great. I think we were at a 100% failure rate. So, we had to go look at this. Now, why is it like that? So, for some of it, we could say, well, it's because we're only actually indexing a portion of the prod data. So, if we're not getting all the data in, it's not going to be a perfect match. That's fine. But there were other bugs. And these are, I think, pretty typical data store bugs. So we wrote the data twice. We didn't write the data. We overwrote data. This is why we weren't running it in production yet. But one of our lessons learned here, and something that the team has kind of taken super to heart, is when you're doing something like this, get visibility into your correctness super early. The other thing is it gives you something to show stakeholders and say, hey, look, it works. Even if it mostly works. They've got something to track. But, we go from this to we're just debugging. And that little orange block, that's metrics and bug fixes, right? So it's just going to keep growing. Our next step was, okay, well, we need to actually get all the data. We think the system is stable. We're going to run it on our production fleet. It didn't make the production fleet fall over, which is what you're all hoping I'm going to say. It actually worked quite well. We were able to do quite a lot from that. It did solve the problem of, well, we're missing data because it's just not coming into the system. Our architecture goes from this to this. It's a little bit complex. There are maybe too many lines that cross one another, but, it's okay. And our little orange bar clicks along. This is one of the best ones. We're sitting here going, why are reads so slow? And when I say so slow, I mean humans are willing to wait like 10 seconds for a really slow website. We were hitting our 1-minute timeout in the back end. And we don't know how much longer it would have taken. I think some of the tests we were doing, we upped that to 2 minutes just to see. That wasn't working too well. And so this one it has a double lesson in it. We had pivoted really fast during the design phase where we thought we were going to put metadata in DynamoDB, which if you have key value data, it's amazing. It's lightning fast. But we were scared of DynamoDB. And so without doing all of the maths, we thought, no, we can get away with putting this into S3. So we've got a bunch of files that we have to search through. And this is where the thing of, when you put more data into a data store, it gets slower. That bit us. And not just us. The dependency that we used to read the data out of those files reached out to us. And they said, hey, so when you make those huge requests, our CPU goes to 100%. Please stop. And given that it wasn't working for us anyway, we said yes. And they throttled our access down to 0. You're not allowed to call us anymore. They had to protect their service. They had other customers. And we were stopping those customers from getting, their data. Okay, fine, pivot. Look at this. We go, okay, back to the original design. Also, do a lot of maths. I got to have some fun putting as much data as I could into a data store and just checking what the timing would look like. That was great. So we went from this. We put DynamoDB back in there because actually it was the right tool for that particular job. And we went from there, just a little bit more dev time. Why not? Then we're trying to investigate this thing. We're debugging. None of it makes sense. We have a complex system which is doing, writing, compaction, bits and bobs. And eventually we look at it and go, oh, we've used lock tables to try and isolate so we only do one thing at a time. And what we've done is we've implemented a queue system badly with lock tables. Now, that's all very well and good. It sneaks up on you. And so we, wrote some designs, had a look at it, agreed if we're going to do queues, we're going to use a queuing system. We might have to add a new dependency to this data store, but it's a dependency Heimdall already has. And so lesson learned here is it's okay to revisit the design and pivot when things aren't working. Just do the due diligence. Check that it's actually going to work out the way you expect. So we have our architecture. Now it's got 3 components. It's a little bit of a complex system. This is the bit where, I could do about 3 different tech talks just on that little box at the top there that has those 3 symbols in it. And our timeline is looking great. Yeah. So that actually brings us up to where we are today, which I was really hoping when I submitted this talk back in November that maybe it would be done by the time I got to do the talk. Optimism apparently runs in my team. So at the moment, what we're doing is that long tail of big projects, bug hunting. We've found some interesting ones. We've found race conditions. We've found spots where we're just leaving data dangling, or where we have data that we thought we were deleting as part of a pruning process, but it's still there. We've got some strange bugs. That's where we're at the moment. Our timeline comes to an end because that's today. And that last little red block that you'll see there, that's me trying to write my slides whilst 2 other services, neither of which are Heimdall, are busy also trying to fall over. So I wrote these slides. I was trying to keep my attention on write this positive talk and also save these other services. It's great. Scale check last month. So it hasn't grown quite as fast. We haven't doubled again. We're now at 12 billion an hour in US East 1. The real trick here is, remember how many things we lost in December 2021, where we were going at 5 billion an hour? If this service falls over right now, I'm going to have a lot of very sad customers. And I'm pretty sure somebody on LinkedIn said 40 billion things an hour, so I just needed to prove that that number is true. This is across all AWS services. 40 billion requests an hour. People keep doing it. People keep using it. This is growth caused by, customer engagement, AWS regions coming online, new services within AWS onboarding with Heimdall because it's useful. And this is kind of where we're at. So I'm going to go back over some of the lessons that we've learned in the last 2 years, multiple times. Major projects like this take time. There's a lot of stuff that can go wrong. There's a lot of stuff that we don't account for. And the true test of your re-architecting is going to be when you put it under production load. So our pre-prod environment of this thing, by the way, has no latency problems. It's perfect. And then we put it in EU West 1 and a couple of US regions, and we're just oh, yeah. So we're 2 years in. We're sincerely hoping to be done this quarter, before July. To be fair, I'm a little cynical about that date. Legacy systems, and that's anything older than 2 years, remember, are difficult to modify. Code grows organically. And humans do some very strange things when they're writing code. Sometimes you think it's a good idea. Sometimes you know it's a bad idea and you do it anyway. I'm pretty sure this whole system has a while true loop in it. So, sometimes you're just not going to know what you're going to find. And that means it takes time. It means the regression testing, the shadow testing, kind of critical. Allow time for unrelated short-term priority shifts. Unrelated to the specific project, not unrelated to your team, not unrelated to your business, not unrelated to you personally. I was one of the devs they had to onboard, which caused a delay in the project. Hopefully I made up for it by writing some code. That sort of thing happens. We don't just have a single, focus. That is the dream of every developer, is to be able to hyper-focus on just that one thing that we're building, and it never happens. We do estimate our amount of time or amount of work based on the assumption that we get to do that, just to make managers happy. When you're doing a like-for-like replacement, ensure that you can visibly prove correctness. This is the way that you earn trust from your stakeholders, from your customers, all of those people. They want to know that the data that you're returning from the new system is the same as the data from the old system, which they have trusted for the last 12 years. If something doesn't work the way you expect, change your design. Make the changes you need to make, do your due diligence, and actually test that it's going to work, do the maths, figure it out, work out how much it's going to cost, whatever it is you need to do. Make sure, but don't be afraid to redesign things on the fly. Nothing stands up to actually developing it. You can have a beautiful design, and then you start writing code, and you realize, hang on, if I write to this design, I'm going to have the most unreadable code in the world. And then you will notice I never mentioned this at all. This is something that this project we have completely failed at, is incremental delivery and incremental improvement of the existing system as we move forward. And so we do this for new projects now, but it's really important, if you're going to do a long-term project, that you have some way of providing value along the way. And even if you can't provide full value, so we have to do a swap at some point from datastore 1 to datastore 2, and it had better be fully correct before we do that. You need clear milestones, clear checkpoints at which you say, by date X, I expect this particular thing to be working and in this state, and you hold yourself to those milestones, to those goals. You give those to your stakeholders, and they come back to you and they say, so, you said you were going to be at this point in the project, can you show us your progress? That, it gives you peace of mind. It really helps your stakeholders to trust the process that you're following. And overall, you feel a little bit less like you're just bashing your head against a wall of code until one day it magically works. So, there we go. I have left myself exactly 6 minutes for your questions. Also, reminder, rate the session. Do it now. You can save and come back later for each talk, so don't feel like you need to do anything like that. All right, we've got a question already.
I just wanted to ask, how do you explain those extensions to the project to external?
How do we explain all of our delays to our stakeholders? With a lot of embarrassment, I'll be honest. It's not something we were good at in the first year. Over the course of this last year, we've got much better at it. We have weekly updates, which we're sending. We have broken down the project into milestones, and we have much better dashboards now, which show this is what our latencies look like under this much load, and things like that. So it's really been about visibility. and not worrying about looking bad. Like, it's absolutely okay for me to go to my stakeholders and say, so we found this new bug, and it's going to mean we take an extra 3 weeks of dev time to fix it. They'd much rather know that as soon as we find it. Yeah.
It's easier because your stakeholders are technical.
Is it easier because our stakeholders are technical? In some ways, yes. All of my stakeholders have either had a project like this before or, have written code, that sort of thing. But I think that same thing about visibility is true even for a non-technical stakeholder. So if you could say to somebody, this is where we were a month ago, this is the graph now, this is where you want the graph to be, they can understand that. And they can understand that it does take time to figure things out. And if you can express unknown unknowns clearly, I think you can explain that to a non-technical stakeholder. And you can express it in terms of things they care about, like the correctness, right? You could say, we could give it to you now, but it's going to take like ridiculously long for the page to load. Or you could say, we could give it to you now, but it's only 90% correct. And so you can kind of have that conversation. One at the back.
Yeah, question, what tips do you have for estimating such a timeline in the future? Or do you just tell your stakeholders it will take as long as it's going to take?
Okay, so repeating the question, do I have any tips for estimating such a timeline in the future, or do I tell stakeholders it'll take as long as it takes? It'll take as long as it takes is not an acceptable answer. I have learned this. My stakeholders, much as everybody else's, want results, and they want to know when those results will happen. One of the things I do is I take a very pessimistic view on initial estimations. I recently did some estimation for another project where I think what I came out with was if we had 4 developers working on this full time, it would take 4 months. But because there is no such thing as 4 developers working on this full time, it will probably take a lot longer than that. And that's sufficient for my stakeholders. It also means that we haven't started that project yet because we know it's massive. So I think it is just about weighing it up. You look at it, if you go, it's a legacy system, just add 2 weeks for working out what the hell is going on in that legacy system. You look at it and you go, I'm going to need to do a full staggered slow rollout. Go ahead and just add 4 weeks just for rolling out safely. Whatever makes sense in your context. But yeah, that pessimistic view. And then if you're really feeling like I don't trust my estimates, double it. Yes. Okay, so this is about how do we keep the engineering team engaged and not quitting over a project which they thought would be 4 months of coding and is now 2 years of debugging. So I do think I have a pretty amazing team because they have kept running with it. I haven't done anything special other than listen to them. And when a dev comes to me and says, this is incredibly frustrating, I say, I agree. Do you have any suggestions for making it better? And if they actually have good suggestions, I will take them with both hands and we will do that. I'm getting in trouble. But yeah, I don't think it's easy, but it's about transparency. It's about listening. John said it earlier. It's about people. Okay, so this is a question about choosing the right tools for the job. Would I change the things knowing what I know today? I think the one thing is we did a lot with Kotlin coroutines. And if you've worked with those, you know that they're really difficult to reason about. I'm not a fan of asynchronous programming at all because it makes my brain fizz. So probably that. But I do think, so we have a lot of constraints on what tools we can use, because the fewer dependencies we have, the less chance we have of falling over. And so I think we've taken a very nuanced view on choosing tools, and I do think that we've made good decisions. I think it's just been about data gathering. So I wouldn't make any major changes. Unless something turns out to be completely broken, I might change my mind in the future. All right, we've run out of time. Thank you, everybody. Don't forget to do the rating. Stand a chance to win those things. And have a good one.